All right. Well, how's everybody today? Fantastic. How's the quiz?
Not so
Okay. All right. Well, I will get those graded before the end of seventh period. I'll have them in front line. I'll be able to pass those back tomorrow. We'll go ahead and talk about it before starting chi-squared. But if you do have any questions, come talk to me. You'll have until next Friday morning if you want to go ahead and retake that. Okay, but let's go ahead and continue. We are talking about correlation, specifically Pearson's correlation coefficient, and we've done several of these by hand, but I have been focusing a little more on the technology. Correlation refers to how tightly packed or how spread apart your data points are when you plot them in a grid. It's a numerical value either between 0 and 1 if it's a positive trend, or between -1 and 0 if it's a negative trend. Okay, we went through several examples by hand and by calculator. We've talked about the formula. Okay, S sub xy, that is known as the, starts with a C, covariance. There we go. Both S sub x and S sub y are the standard deviations for those respective sets. And in order to find R, you take the covariance and divide it by the product of the standard deviations. Okay. Then we started, let's see, where are we? That's the filled in table. Okay, there's the assignment. In fact, when's the assignment for correlation due? It is due tomorrow. Okay.
Everybody in group 4, so anybody in an IB science is not going to be here tomorrow.
Okay, how many people does that apply to?
A lot.
Oh, wow. Oh, my.
All day.
What is this?
It's like science, biology, and chemistry.
Ooh.
Yeah.
Okay. Wow, with that many people gone, I may end up just waiting until Thursday to go ahead and start chi-squared, because that's a really super important topic. So I guess what we'll do tomorrow is definitely pass back the quizzes, talk about them. And if you're not here when we do that, definitely come on in so I can help you. John Henry? Well, now we can't wait until the next week starts. Yeah. And also what's happening next Thursday. You got your second exam coming up, so yeah. In fact, I've already started putting that together. On Thursday, the 19th of next week, you have your second exam. I put normal distribution on there, some standard deviation, measures of central tendency, specifically mean. There's a cumulative frequency problem on there, and I did put correlation. Okay, so all that stuff's going to be showing up. Jacob?
What week of the 6 weeks are we in?
We're in, well, I count that half week. I'd say this 6 weeks is 6.5. So we're in technically week 4, because a lot of people don't count that half week. So after this week, there's only 2 weeks left in this 6 weeks. Okay, so it's going really fast. I mean, time flies when you're having fun. Okay, I agree. Okay. All right, and this is what we started talking about yesterday. We went ahead and looked at a problem where we created a scatter plot, and using our algebra skills, we came up with a line of best fit, a trend line, a regression line, again, whatever you wish to call it, for, I believe it was centimeters, okay, the height of players, and then the weight in kilograms. We're talking of hockey players here. Okay. And unfortunately, I did make a mistake with the notes. I do apologize about that. You have the copy of the notes here. All right, so we are good to go. So what I want to go ahead and do is just move on past this problem here. Okay. I want to go ahead and talk about a few of the ideas on this, and then we'll go ahead and just do a couple more problems focusing on the calculator. So let's see, the least squares regression. The problem with finding the equation of the line of best fit by eye is that each person could have a slightly different line, and we referred to that yesterday. Therefore, we use a more mathematical process based upon the square of the vertical distance between the line of best fit and each data point. So you'll notice here's my regression equation. In fact, does the form look familiar to anybody? We actually used it yesterday when we wrote ours. It is point slope. Okay, so the form they're giving you here is in point slope form. Okay, but while we have the point, the grand mean, made up of the mean of the x's, the mean of the y's, they're finding your slope in an unusual way. Now, we're not only going to be able to use the technology to provide me the slope, but I'm also going to show you how this expression will work as well. And there's actually a few variations of it. So the slope of your line can be found by taking s sub xy, the covariance, and dividing it by the squared standard deviation for the x's, your independent values. Okay. Now, you could also do this. It says, note that the slope, what I just showed you before, is equal to r, your correlation coefficient, times the standard deviation of the y's divided by the standard deviation of the x's. Okay, now, you think this would be one of those little obscure facts that we don't need to worry about, but I have actually seen that show up on one of the paper exams. Okay, so this is definitely something maybe we want to go ahead and put a star next to, highlight it, whatever, because that's definitely a ratio we do want to remember. That will come back. All right. Well, let's take a look at a problem. And you'll notice, let me go ahead and erase this right here. Okay. This is the exact same problem that we were looking at yesterday. Now, we did it by hand. Why don't we go ahead and walk through how to not only input the data, but get the trend equation like we did yesterday. So I'm going to go ahead and take this set of notes because I am not going to remember all that data. And let's come on over here and input it, all 21 data points. Okay, so I'm going to go home. Okay, so we always start with new document, or you can come down here to the spreadsheet icon, again, whichever you choose. Okay, now here we do have specific quantities that we're comparing, height and weight. Again, I'm just going to go ahead and put in X and Y. You can label those however you prefer. Okay, and follow along. We have 183, 170, 174, 168. 167, 177, then we have 162, 167, 169, 163, 161, 172, 160, 160. Okay, then we got 167, 171, 170, 174, almost there, 162, okay, then 187, and 175. Okay, there are my X's. What was that shortcut to jump back to the top row? Control 7, so I don't have to scroll. And then now for each of those, let's put in the Y values. 85, 74, 76, 69, 68, 74. Then we have 62. Okay, 67, 74, okay, then we have 67, 69, 74, 64, 62, okay, 74, 64, 62, 72, 69, 76, 71, 71, 84, and 77. And that worked out nicely the first time. Good. All right. Well, the keystrokes here are actually going to be very similar to what I've already shown you when it comes to standard deviation, finding that information. Choose an empty cell in your spreadsheet. Okay, doesn't matter where. I'm going to go to menu. Okay. Where do you think I'm going to go first? Statistics. Which of the 40th believe? Okay. I want stat calculations. And this is what? Two variable statistics. We are comparing two different sets of data, two different quantities. Okay, so X list and Y list, those are the headings that you originally put in. I just chose X and Y. I accidentally typed that. Okay, tab, Y. And again, the frequency list, even if you go ahead and delete it, it's going to pop right back up, so don't worry about that. Looking for D. Okay, click OK. Now here's all the information, again, ending with the main points for your box and whisker plots. If you start to scroll up, you'll have everything else you need, the individual standard deviations, but here is my correlation coefficient, R. Okay, so about a 0.88. Okay, so how would you describe the data? Strong, weak, what do you think? I'd say definitely strong. Remember the intervals that we were looking at on the other set of notes, I believe it was from 0.75 to 1 was going to be considered strong. Okay, so definitely looking at some good data here. All right, now here's what we're going to go ahead and do if we want to not only see the scatter plot, what we did yesterday, but also get the equation line. Okay, so once you have this information, go ahead and click Home. You want to go back to your home screen. Okay. And now right down here, it looks like the histogram. This is data and statistics. This one right here next to the spreadsheet icon. We want to choose this one right here. Now, as soon as you choose that one, okay, it's just going to take all 21 of your ordered pairs and it's just going to throw them on the screen. This is the one time where none of our screens are going to look the same. So we have to tell the calculator how to go ahead and set it up according to the axes. So I'm going to click Tab. Okay. And you'll notice at the bottom, X and Y, the two headings I typed in came up first. Always choose the X, the first column first. See, it sets them up horizontally. Then I'm going to click Tab again, and this time I'm going to choose Y. And see, it gives me the scatter plot that we created yesterday by hand. Okay, when I had some folks come up here and help me with those ordered pairs. Anybody need help with that? Okay, we chose Data and Statistics, Tab X, Tab Y. Okay. Well, now we want to go ahead and not only see the trend line, the line of best fit, but we also want to go ahead and have it calculate that equation for me. So I'm going to go to Menu. Does anybody think they know where to go? Analyze. Anything look familiar? Regression. See, that's another one of the terms we use to describe this. So analyze regression, and you're just going to choose the first one. Show linear mx plus b. Okay, so as soon as I click it, see it not only draws the line, but it also gives me an equation for that line that I could use. Okay, so let's say 0.74x minus 54.22. So 0.74x, let me get back over here. 0.74x minus, well, I believe it was 54.22. There you go. Now remember when we did this by hand yesterday, I think we came up with a slope of 0.5, right? Yeah, we came up with a slope of 0.5, and how close were we on our y-intercept? That one we were a little further off, okay? And that does happen, especially when you're choosing your own points. Sometimes you may choose some really nice points, but it also depends on where you put your line, okay? So definitely the technology is the way to go on this, especially if you're looking for more accuracy. All right? So any questions about how I got to this point right here? Okay, well, let's go ahead and take a look at another example. In a study of a city, the population density Y was compared to the distance from the city center, X kilometers, for a number of sample areas. Okay, here are the results. Find the line of best fit of this data using the formula, okay, and find the correlation coefficient R, given that the covariance S sub xy of the data was calculated to be negative 12.472. Now, they're wanting you to go ahead and calculate the slope. Now, actually, they'll probably want us to go ahead and do this one by hand. We'll go ahead and calculate the slope by hand given the covariance, but everything else, we're just going to go ahead and rely on the technology. Okay, so I need to take this data and put it in the calculator. So how do I remove the data that I already had in there? Okay, Control W. Okay, so I'm going to come on over here. So I'm going to hit Control W. Do you want to save those? No, and I'm starting all over again, fresh. Okay, so new document, list of spreadsheets, okay, X and Y. Okay, even though we have, population density and distance from city center. Okay. All right, let's see what are these values here. So we have 0.6, 3.8, 2.4, 3.0, 2.0, 1.5, 1.8, 3.4, okay, 4.0, and 0.9. Okay, so I got 10. Going back up to the top, Control 7. Okay. Now 50. Oops. 22. what do we have? 14, 20, 33, 47, 25, 8, 16, 38. Another example of life just teasing me. 16, 38, just doesn't have the same ring to it, you know what I mean? I get so close, it's just like it's right there, I can't grasp it. Okay. All right, questions about putting the values in. Okay. All right, so here's what I want to go ahead and do. Let's not go ahead and plot the points. Let's not worry about getting the equation of the trend line yet. I want to go ahead and work with finding the slope using that ratio. Okay, so how would I go ahead and find like the standard deviation and the correlation coefficient and all that stuff? Okay, so menu, statistics, stat calculations. This is two variable statistics. Okay, remember if it's like a frequency table, it is just one variable statistics. Okay, let me go ahead, choose X, tab, choose Y. Don't worry about the frequency list. Everything's showing up in C. I'm going to click OK. All right, now we have everything we need. Okay, so let's go back over here very quickly. Okay, so one of the things we saw, I can find the slope by taking the covariance, which was already provided for me, and I can divide it by the squared standard deviation for the x's. Okay, so let me come on over here. Okay, so what was the covariance that they gave me? Let's see, negative 12.472. So I'm going to go ahead and use this space up here. So S sub xy divided by S sub x squared. So negative 12.472 divided by, now let's figure out what the standard deviation for the x's was. Okay, there we go right there. Okay. So with such a large decimal, I might definitely go ahead and round it to 3 or 4 significant figures. Let's go ahead and say 4 sig figs. So 1 point what? 1.125. Okay, now remember, I am rounding this, so will that have an effect? Yes, the more decimal places I take, definitely the more approximate it's going to be, but I'm just going to go ahead and say 1.125, let's say. Okay, so 1.125 squared. Okay, so I'm going to come back over here. Let me go back home, calculate. All right, control divide. I know it was negative 12. Whoops. Okay, there we go. Negative 12 point, and what was that? 472. 472, and I want to divide that by, what was it, 1.125? 1.125 squared. Okay. So there we go.
I got lost.
Okay. Where'd I lose you?
You started talking about the standard
Yes.
deviation.
What I'm wanting to do is show you, yes, I want to show you that that ratio is going to give me the slope. Okay, so what I did, at the top of your page, I'm using this ratio right here. I took S sub xy, the covariance, and I'm dividing it by the squared standard deviation for the x's. So, sigma. Did I choose the wrong one?
I don't know.
It's very possible.
It's got X, so I got confused.
Okay, for current, come on. There we go. No, I choose sigma x. Now, even though its notation uses the x, remember in IB we're always going to use the sigma x for our standard deviation. Okay? Yes, Stephanie.
So where did you do
The covariance was already provided for me in the problem. Okay, so if I come down here to the problem, okay, go ahead and determine the slope given that the covariance is negative 12.472. Okay. So I actually want to see how close we're going to get using this. Now I got, if I go back to my calculates pad here, I got negative 9.85. Is that what everybody's getting? Okay. So why don't we go ahead and now have the calculator determine what the equation of the line of best fit is, and let's compare our slopes. Okay. So I'm going to come back over here. Okay. Let me go to my document that I have this open. Oh, actually, what am I doing? I need to go home. Remember, I'm going to choose this right here, data and statistics. It looks like a histogram. All the bars are tightly together. Now I'm going to go ahead and do this over here, just in case it doesn't sense the finger. So I'm going to click Tab, And which one do we always choose first? Always choose the X's. Okay, label the horizontal first, the first column. So there we go. Then I'm going to click tab again. This time I want the Y. Okay. Well, so far it's looking good because we have a negative trend. We did end up with a negative slope. I'm going to say menu. I remember we go to analyze. Where do we go from here? Regression. And then MX plus B, show linear. Okay. So as soon as I click it, there you go. In fact, what did our slope turn out to be? Negative 9.84839. We got negative 9.85. Okay. So that ratio does work. It's another way to calculate your slope. Okay, and what we end up with here? Negative 9.85 plus 50.35. Okay. All right, so I'm going to go ahead and work this out. Y is equal to negative 9.85x plus, I know it was 50.35. Is that right? Okay. All right. Well, the only other thing I want to bring up, because we're pretty much at the end here, is everybody okay with what I did? Okay, yes.
Sorry, where did you get
Oh, the negative 12, that was provided to me in the problem.
Oh,
They already provided me that covariance. Okay. All right. Now, if you want, you can also check this right here. We know the correlation coefficient. We just found it on the calculator. We didn't specifically look at it, but you could take the correlation coefficient R times the ratio of the standard deviations. If you were to do that, you should get very close to negative 9.85 as well. Okay. If you wanted to go ahead and do that, I'm not going to worry about that right now. Okay, good, good, good. Okay, well, the only other thing I want to do is bring up a couple of words, what we refer to as, oh, had that copied down from last time, what we call extrapolation versus interpolation. Extrapolation versus interpolation. Okay, let me go ahead and pull these guys up here. Okay. Can you mind telling me what those mean, what we're referring to when we're talking about a set of data? Okay, so data that falls inside the given set. Which one is that? Extrapolation or interpolation? Interpolation, yes. That's when you're looking at data within a given set. Now, extrapolation is just the opposite of that. That means you're looking at data outside of your given set. Okay, now what you always want to do is look at data within your set because you don't know if there's any variables that we don't know about that could be affecting the outcome. You only have the one snapshot of information, your set of data. So when we talk about extrapolation, we don't really want to go outside the set of data that we have. It's probably okay to go a little bit out, but you definitely, the further out you go, the less likely your answers are going to be legitimate. Okay, so this one here, it says use your line of best fit to calculate the population density, given that the distance from the city center is 1 kilometer. Okay, so what do they provide me here? They provide me the X or the Y value? Yeah, they're giving me the population density, so that has to be the X value, right? So see, I have a prediction equation. I can now use that value and see what I'm going to get for the population. In fact, all I got to do is plug it in. Let's see, I'm going to go back over here, calculate. Let's see, negative 9.85. This isn't necessary, but I'm going to go ahead and times it by 1 anyway, plus, what was it, 50.35? Okay. So we end up with a population density, I'm getting 40.5. Okay. Now, would we say that's pretty reasonable? Yeah, because this value of X belongs to that set of data. What's the smallest X value we have here? Okay. All right, and what's the largest? Okay, looks to me like it's going to be 4. Okay, so anything between those values, this is probably going to be a pretty reasonable prediction. So if I were to say, okay, what if somebody is, what are we talking about here, kilometers? What if somebody is 15 kilometers from the city center? How reasonable do you think your answer is going to be? Probably not very reasonable. That 15 is well outside the set of values we have for x. Okay, so that's what it means to have an extrapolation. This right here, x equals 1, is an interpolation because it's within the data that we already have. Is everybody okay with the difference? Does anybody have any questions on that? Okay. We're good? Jacob thinks so? Okay. All right, well, let me go ahead. What is it you're going for tomorrow?
Group 4.
It's group 4.
It's what they keep calling it.
Okay. And how many people will be gone?
I think it's everyone.
Except me.
So it's basically everybody except 2 people. So it's going to be a ghost. It's going to be a ghost town tomorrow. Okay. So I'll tell you what I'll do. The homework was originally due tomorrow. Why don't we just go ahead and push everything ahead of date? Okay. Let's go ahead and have the correlation homework due Thursday. All right, that'll give you a little extra time. Now, you'll notice on the board, I do have the assignment for linear regression. It's only a couple of problems. I was going to have this due Friday. Would you like to keep that so that you don't have any homework for the weekend, your 3-day weekend, or should I move that to Tuesday? Let's take a vote. How many people want it on Friday? 1, 2, 3, 4, 5. How many people want Tuesday? Okay, not everybody's voting, but okay, the group did decide. So the linear regression homework will be due Tuesday. Correlation homework is now due on Thursday. Okay. And then Thursday, we'll go ahead and start chi-squared. We'll be a day behind, but that should be okay. And then next Thursday, we'll have our test. Okay. All right. So I've got 206. Let's go.